Good afternoon, everybody. Thanks for having me here today. As Richard said, I'm an architect who specializes in sustainable building. Currently, I work here in Montpelier at a firm called Gossens Bachman Architecture. But in the past 18 years, I've been practicing. I have worked all over the country. I used to work in Washington State, where I'm licensed there as well, Wyoming, and Colorado. So I've worked firms in all of those places. I'm committed to socially conscious projects and creating beautiful and sustainable buildings that are suited to place. I'm passionate about architecture. I believe that as the world changes through population growth, decreasing biodiversity, the architect can help lead through change and rethinking the design of buildings and communities. The architects can create positive change through both collaborative and thoughtful design. So what we're going to talk about tonight, we're going to talk about green building, what it is, and the importance of reducing embodied energy, total embodied energy that is consumed through the life of a building. We're going to discuss why we should build green. We're going to discuss strategies in ensuring a building is green. And then we're going to look at case studies, my favorite part, because we look at lots of pictures, on examples of green buildings that are suited to place. I have selected examples of projects that are both international and local, and they range in size and approach to green building. The first case study will be some international work that uses an international green building system, and that's a K through 12 school in Bulgaria. We'll look at a more local certification program in Vermont with a building here. And the last two examples use alternative building techniques, Rammed Earth Library in Pinedale, Wyoming, as well as some earth bag projects in rural Nepal. Just a little.
Forward your slides and you can.
Oh,
Okay.
no.
Get your laser pointer.
I gotta have my little pointer. It's just a little lag here. So green building, and I got this from the United States Green Building website, which is kind of the leader in green building design right now. And they say the built environment can have profound impacts, both positive and negative, on the natural environment, as well as the people that inhabit them. Green building is an effort to amplify the positive and mitigate the negative of these through the life cycle of the building. Those considerations are energy use, water use, indoor environmental quality, material selection, and the building's effects on site. It's a little lag here. So why do we want to build green? 39% of total energy used in the US is actually because of buildings. 12% of the total water consumption in the US, 68% of the total electricity consumption, and 38% of carbon dioxide emissions. A little bit of a lag here. Okay. Out of the total energy use, 53% is residential building and 46% is commercial building. And if you guys need to come around, or you can probably look at my slides, but you might want to go to the back a little bit if you can't see the slides. So if we're looking at the indoor environment, we look at combustion the pollutants in there are combustion sources, I can't say that, building materials, furnishings, household cleaning products, maintenance items. All of this contributes to stuff that's in the air. And this is all from the Environmental Protection Agency website as far as statistics goes, but on average, Americans spend 90% of their time inside. So then they say indoor air pollution is 2 to 5 times higher than outdoor levels. So when we think about building green, we're thinking about the health of our occupants too. Sheesh, it flips. Carbon dioxide. Buildings in the U.S. contribute to 38.9% of the nation's total carbon dioxide emissions. Heat islands. Heat islands are basically, if you guys don't know already, they're basically the hard surfaces that you'll find out, at your buildings and in infrastructure. So roadways, asphalt, roofs, those are kind of heat islands. They absorb heat. And this says that in a city of 1 million, the average temperature can be increased by 1 to 5 degrees. And then it can be as high as 22 degrees when it's summertime. So we want to think about these surfaces. Building occupants use 13% of the total water consumed. And on average, the average American uses 100 gallons of water a day. That's a lot. But that includes irrigation. But you know, it's showers, it's toilets, it's flushing. Stormwater runoff. So the impervious surface coverages, we talked about that, you know, where the heat islands are. So roofs, paving. In the U.S., it's about 83,000 square kilometers. So it's a lot of surface area. And why we care about that is because these impervious surfaces, they basically, instead of water filtrating back into the ground, it just collects the pollutants on top of it. So if you have an asphalt roof, all that junk on there flows off and it gets into your water sources. So we want to be conscious of that. Materials and waste. Building-related construction and demolition debris account for nearly 26% of total non-industrial waste generation in the U.S. So if you take down a building, or if you're even building a building, all that waste has to go into a landfill. So we have to be conscious of that and how long buildings last and if they really need to be built. So just in summary, your green building benefits, environmental benefits, enhance and protect biodiversity and ecosystem, improve air and water quality, reduce your waste streams, conserve and restore natural ecosystems. Economic benefits, why do we care? Well, we have clients, and so, you know, if you can tell them you're going to reduce your operating costs, that's fairly important. Then they'll say, okay, maybe we will build green, expand and shape markets for green products and services. The more green products you use, the more money they have to build better, to create better products, and improving occupant productivity, natural daylight, healthy environments. Social benefits, enhance occupant comfort and health, heighten aesthetic qualities, and improve overall quality of life. So how do we build green? So some tools that we have this, the United States Green Building Council has a checklist called LEED. It's Leadership in Energy and Efficient Design. And it goes through all these categories, but there's other checklists. The EPA has a checklist. Cascade Institute has an even more strict checklist called the Living Building Challenge. And locally, Efficiency Vermont's got a checklist as well. So there's a variety of strategies. I've used LEED quite a few times in projects. I've worked on and led 5 LEED buildings. These are categories that you kind of run through that address the issues that we were talking about earlier. So there's the integrative process. It's not exactly a category, but it's if you're going to build green, you need to start early. Everybody needs to be on board. Sustainable sites, we talked about that a little bit, is, you know, you're encouraging strategies that minimize the impact on the ecosystems and water resources. We look at water efficiency. How can you build and use less water? Energy and atmosphere, so promoting better building energy performance through innovative strategies. Indoor environmental quality, promoting better indoor access to daylight and views, and materials and resources. It's a little slow on the slides here, but that's okay. So what's not on any of these checklists, and what I think is really important, is that you need to create buildings that are beautiful. They need to be adaptable, they need to be durable. And if you create beautiful buildings that people cherish, then they'll want to save them, and then you're not putting stuff into landfills. You want spaces that fit the client, that can be reused later. So now we're going to look at photos if it comes up. Huh. All right. So the first case study is the Anglo-American School of Sofia in Bulgaria. We did this internationally, obviously, and it was a LEED for Schools checklist, and we got gold certification. I did this when I was working at Truex Collins, and I was the project architect. This project was started in May 2008 and was completed in September 2012. So it was a 4-year project. Some of these things take some time. So what you're seeing on the overhead is Bulgaria. Basically, we have a little map up there. And so Bulgaria is located in Eastern Europe and is basically on the edge of where East meets West. This has had a profound impact on the culture and the vernacular architecture in the region since Bulgaria was ruled by both Ottomans and Romans. Sofia is at the base of the Balkan Mountains, and then you can see it up in the upper, ooh, can you see my little cursor? You can't, bummer. Okay. So basically, Sofia is the city right there in the upper left, and you can see Mount Vitosha in the background, which is part of the Balkan Mountains. The campus itself lies just south of the city. And right down below, you'll see a Roman amphitheater. This was in Plovdiv in Bulgaria when we were kind of understanding the place. And to the right, the lower right corner, you'll see kind of some typical vernacular local architecture. So great wooden brackets, a lot of color used in the vernacular architecture. So we look at all these things when we're going to a place to really understand the culture. So the original school opened in 2006. It was a K through 12, and it was built for 350 students. These are diverse schools that we work on with a diverse student body that is comprised of students from more than 40 countries. In 2008, we were asked to develop a master plan for the school to expand to 450 students in 5 years and 650 students in 10 years. This included a new 9,300 square meter high school and middle school and a renovation to the original school to transform it into an elementary school. So on the overhead, you'll see it in light brown, that's the original elementary school, and the brown area, which is just about the same size to expand it, that's the new middle school and high school. You'll also see, for those who can kind of see the overhead, there's up in the upper right corner, there's a constructed wetland. We also have photovoltaics and green roofs on there that we'll talk about as we go. So from the outset, the school established earning certification under the LEED Green Building Rating System as a project objective. The new building required a separate entry from the elementary school so that the middle school and high school students would have their own identity. However, it was important to have shared common spaces. The solution was to create an amphitheater that cascaded up the sloped hillside and linked the two buildings. Also at this juncture, we placed the library in atrium space. I don't think you can see my cursor. The new building design consists of classrooms, library, administration, technical rooms, lobby, gymnasium, locker rooms, and support and service rooms. The performing arts building, you can kind of see it in the lower left, it says Future Arts Building. It was planned for, but has not been built yet. But it will be built at a futures phase, and that contains a full theater and arts rooms. We like to think of it as a modern interpretation of the vernacular architecture. So again, we always, when we build, we want to go, we want to visit, we want to understand the culture and really kind of get into the place so that whatever we build, it's very, very custom for the site, very custom for the users. So with Green Building, I talked about an integrative team approach. We met with all the players of the school, not only the senior leadership team, but the staff, students, PTA, and other organizations. We checked in frequently with the same groups to get opinions throughout the design process. This collaboration is essential for getting to a design solution that fits the community. During construction, this process was also very collaborative. The school hired the contractor early in the design process, and we put the design team together early, and it was actually quite a huge design team. It was consisted of not only engineers, but energy modelers, hydrologists, geologists, a stormwater modeler, a road engineer, and a landscape architect. We use this process, not only do we use this process abroad, but we also use this integrative process here in the States. We do rely more heavily on technology when we do work, if it's cross-country or if it's abroad. But we also go over to the place quite frequently. So we were checking into Sofia every couple of months. And over to the right, you'll see the the school that was the 2006 campus, and to the left where the amphitheater is, you start to see the high school and middle school in its new entry. All right, I have to double click. Okay, so this is sort of what the checklist looks like. So sustainable sites is our first category. In yellow, you'll find the items that we went through and the items on the checklist that we met. And in the gray are items that weren't necessarily applicable, but we did review thoroughly to see if we could get them. So an environmental site assessment was carried out to ensure the site's history did not present any potential pollution or health risks. We did a transportation management plan to reduce the transportation-related carbon emissions. So we looked at van pools, alternative transport, and preferred parking for carpools. We reduced the heat island effect with light-colored hardscape materials, high solar reflectance roofing materials, and green roofs. For light pollution, we took special care to look at the external lighting solutions, but we had to consider security, so it's not like we could totally eliminate lighting, but we created a lighting that had like high, they had not reflectors, but they had cutoffs so that we could focus the light so it wasn't getting into the neighborhood. We developed an erosion and sedimentation control plan so that during construction itself, measures were aimed at reducing or eliminating construction-related dust, erosion, and excessive noise. So this is a view of a xeriscape garden. This is a view of a constructed wetland, which I'll talk about in a bit. For water efficiency, the water management system of the building is perhaps the most impressive example of holistic design and sustainability. By combining existing technologies in new ways that simulate the closed-loop water cycle found in nature, the school will be reducing the use of potable water by approximately 75% when compared to a conventional building in the US. We use waterless urinals, dual flush toilets, and aerators on the sinks. As far as the water cycle features, we had large rainwater systems that we put underneath the building. These captured water from the roofs and stored it there for reuse. This provides a sufficient volume to meet 100% of the school's sewage conveyance needs and the surrounding campus's minimal irrigation needs. A green roof was created to act as a storage buffer and a biofilter for the stormwater. We use pervious open grid pavement in the parking spaces to allow precipitation to naturally infiltrate into the ground. We used a mud and oil separator to ensure stormwater recovered from the roadways is properly treated prior to being recovered and stored in the pond. We use xeriscape gardens and green roofs, and this uses native plantings and species. At the grass field, we used high-efficiency sprinkler heads, drip irrigation, and precipitation sensors. We only had one field that we had to do this with, but it was one item that we couldn't let go. They really wanted a field that was always in good shape. A stormwater catch basin was constructed to ensure the development manages 100% of stormwater on site. A stormwater modeling was used to demonstrate that the strategy could manage a storm at the 95th percentile storm. And the constructed wetland, which I showed earlier, was built to treat stormwater and wastewater on site. The effluent is treated on site and then sent to a subsurface wetland where it is further treated by the nitrogen and phosphate-hungry native plants, which then further polishes the water. This biofiltration system is used as a real-life laboratory for the science classes. There was an online water monitoring system which was installed to help ensure treatment of the system was always functioning. And the water is then gravity fed into the stormwater basin where it naturally filters into the ground and rejoins the natural water cycle once again. This helps recharge the groundwater levels, which has been falling in the region. Energy optimization. So for energy measures, we created super insulated exterior walls and roofs. so we could control the mechanical systems better. We did use natural ventilation, and that serves most of the building's regularly occupied spaces. For renewable energy, we used a hybrid thermal solar system of the building. It augments the boilers to reduce energy used for heating water, while the 7 kW photovoltaic system provides covered parking and contributes to reducing the electricity the school uses from the grid. And you can see the photovoltaics right there in the parking area. The lighting system uses efficient fixtures and daylight sensors. Passive solar design strategies were used primarily to heat the southeastern facing parts of the building. These are the area where the most voluminous corridors are located. We also used a building management system installed to control primarily the heating, ventilation, and lighting. And with all these measures, it is anticipated that the energy savings will be between 38 and 41% over the international standard, which is ASHRAE 90.1. Photo of the gym. Oops. Okay, and this is the lobby. This is south-facing windows. Despite the early stage of Bulgaria's green building market, the project team strived to utilize sustainable building materials. Where possible, we used regional source materials and materials with a high recycled content. For example, the rebar in the concrete was made from 90% post-consumer and 5% pre-consumer recycled steel. The linoleum flooring contains a high percentage of quartz, which is a rapidly renewable material. More than 20% of the building materials were sourced locally. Construction waste was separated on site, and 65% rate was achieved. In addition, a minimum of 50% of the wood used was from the FSC lumber, which ensures sourcing exclusively from sustainable managed forests. The last category we looked at was indoor environmental quality. This is something that often goes unnoticed. It's related to the improved indoor environment. Less off-gassing and toxins and more fresh air in buildings keep occupants healthier and better, and provide a better environment and more conducive to teaching and learning. So this includes basically using materials that don't have any volatile organic compounds, which are known carcinogens. So we were very conscious about paints that were used in the building, primers, lacquers, all of that. We made sure that they had no VOCs. Ventilation, we made sure that rooms that had cleaning products in them or copy machines, we made sure that there was negative pressure so that it didn't disperse throughout the school. We hired an acoustical engineer that made sure the rooms were conducive to learning. So that's important so they're not too reflective. So I'm going to show a couple more photos of this building. Example of a classroom. That's the atrium between the elementary school and the high school. That's where the future Performing Arts Center is going to be. It's currently a xeriscape garden. You can also see the pervious pavement. Photo of the amphitheater. Again, this is all local quarried stone. A view coming up the interior stair by the amphitheater. A view of the library. And these are shared spaces with the elementary school and the middle school and high school. Okay, this is the kind of photo I like to see with lots of people in it, because it says that your space is actually being used, which is most exciting. So the sustainable building approach used by Anglo-American School of Sofia resulted in an improved student experience, a reduced the environmental impact, and significantly reduced utility bills for energy and water as compared to a conventional built facility. The next case study is the King Arthur Flower Campus Expansion and Renovation Project in Norwich, Vermont. We started design of this project in May 2010, and it opened in September 2012. And I'm sure some of you guys have been there since it's only down in Norwich. It's a pretty fun place to go. So this, the client, though, for those that you don't know, it's a 100% employee-owned Vermont company. It's a producer and retailer of flour and other specialty baking goods and supplies. It has a professional bakery and a bakery education center. King Arthur Flour has 3 distinct business units. It has a baker store, a bakery, and a baking education center. And they were all housed originally in inadequate and undersized facilities divided between 2 separate buildings on their Camelot campus. The experience of visiting the campus and buildings did not match the qualities and standards established so carefully in the brand of this nationally recognized retailer of flour. So our responsibility was programming, site and building design, and documentation through construction administration. Our environmental goals we set early, and we decided to use a local program from Efficiency Vermont. The program was called Core Performance at the time. They've now named it something else, but it really focuses on reducing energy in the building. And so the features involved with that are just, again, having a really high performance thermal envelope, so really insulated walls and roofs so we can control the mechanical equipment. We used high efficiency air-cooled chillers, energy recovery ventilation, variable speed fans and pumps for lighting, occupancy sensors, bi-level control, low lighting, power density. We commissioned the building so that we had a third party look at all our mechanical systems and make sure we're operating efficiently at the end. So the pros of this system, whereas LEED you often spend probably 1% of construction costs might go into green building. With this, the owner actually received $30,000 back at the end from Efficiency Vermont. So that's definitely a pro. The con was that it only, the program only measured energy efficiency, and so it excluded things like siding and materials and indoor air quality. So here's the sketch. We often do this when we first get to a site. We look at the pros and cons of the site, what's good, what's not working, what's working. So visitors used to arrive on the site on an asphalt parking lot. So over to the left, you'll see a little drive. It used to go basically between the bakery and the retail operation. There were 2 buildings. So the separation of these 2 buildings thwarted collaboration between this 100% employee-owned, very collaborative company. They had an existing 12-sided timber frame retail building that did not have a clear sense of arrival or point of entry. It shared an undistinguished exterior detailing with a 1-story bakery and bakery education center across the street. And so if you see in the little purple circle, that is where the existing timber frame structure was. And at the top of the page where it says landscape, there was a building up there but right off of US 5 that sat there. So the existing buildings were poorly insulated, had inefficient HVAC and ventilation systems, and had chronically leaking roofs. The most signature feature of the existing building was a 3-story space with a clear story monitor and artfully carved sheath of wheat at the center, and that was all in that little purple area, was the original structure. So we had 3 main goals. One was to create, and I'm going to show you the master plan. So this is the master plan that we came up with. So our primary goal was to create a rival experience that took advantage of the unique site and building. The first view when you come into the campus, we created a new access road, was over the reflective surface of an existing pond, looking towards the roofs of the campus. And what we did was we took the road and we kept the open fields, but we had it, just come around the wooded area of the site, and then the approach then was from the south, so it was more of an experience. And we deliberately configured to lose sight of the building complex behind the rolling fields and then reveal partial views of the monitors over grassy mounds before finally arriving to the south. We had the upward sloping roof porch, which you'll see in a second, that rings one side of the courtyard, then leads the visitors past the new retail addition to the main entry. which was which at the center is the existing retail 12-sided timber frame structure. So here is a building plan of what we came up with. Our second goal was to create a building solution that promotes collaboration and highlights the connections between the three business units, the bakery, retail, education center, and bakery. The space is occupied, we created a U-shaped courtyard that promoted collaboration. There was an internal corridor that you can see that also, so if you're inside or outside, you can see all three spaces. And so there's more of a collaboration with this kind of configuration around that courtyard. We also put the timber frame structure we kept right at the heart of the building, and so that's that circular form. And then we opened up the space so that in the center you can see all the way up to the existing clear store. It's a really beautiful Doug fir timber structure, and we really didn't want to lose that. We just thought that was pretty marvelous from the existing building. So upstairs we had administration, but we walled off with glass that little circle you see in the center so that you can look all the way up. This is the sign, and I'm just going to go through some photos here so you can get a sense of the building if you haven't been there. This is when you first enter King Arthur Flower, looking across the the pond. And this is on the path. Those little stripes there are supposed to be wheat, but they didn't grow when we took these photos, so they're just stripes in the grass, but it's supposed to be wheat. This is looking at the roofs across one of the berms. This is the south-facing courtyard. And this is how you enter the building under this new pergola space. Courtyard.
Questions, okay.
Okay, I'll try. What time do you want me to finish?
Maybe 5 minutes or so.
Ooh, I'm
Yeah.
gonna miss my other case studies.
Yeah.
If there are no
'Cause I
questions, we
asked
can.
all the- This is our only green building speaker, so it's our only chance to.
I know, but I have lots of photos. We like photos. Okay, so our third goal was to develop a modern material and detail language that is sympathetic to the existing building and rural context. So in the interior, you'll see this is a glulam Doug fir structure that was so that we didn't use old growth. You'll see the metal connectors, which are a more modern connector, which we thought was important. This is just sketches that we do when we're designing, but these are sketches of the timber structure. Steel is in tension, wood's in compression, which is so the structure is expressed. You see the new cafe on the lower left is the existing. Sorry, that's the existing timber structure that we reused. Detailing. The project was a success because it's an energy efficient building that works well for the client. It's beautiful and the people continue to use it and it serves its purpose. Okay, I'll make this one quicker. Okay, the next two case studies talk about natural building, and it's a building that minimizes the use of products that require considerable embodied energy for their manufacture or transportation. This is a rammed earth building, Sublette County Library in Pinedale, Wyoming. So the site is in Pinedale. It's south of Jackson Hole on the eastern slope of the Tetons near the Wind River Range. Summers are hot and arid during the day, cold at night. Winter temperatures can be as low as -40 degrees. Natural gas drilling is a big employer in this region at this point. This addition to the Sublette County Library serves as the counterpoint to the existing log structure library building. The new building acknowledges the significant changes in the county by choosing a modern addition that contrasts with original, which has become a community icon. To minimize disruption of the existing facility, the new building only lightly touches the old, creating a courtyard in between them. This walled courtyard garden connects the two buildings with stone pavers, water, and glacier erratics carefully placed to create an outdoor reading room. The new structure runs parallel to the existing library on the north-south axis. On the south side, a large community room lives under a shed roof rising to clear-story windows shaded by a large overhang. This houses a new community center and the Western Collection. So on the right, you can see the addition that we did a couple years ago, and on the left is the existing timber frame structure. So the owner's representative was a librarian with a vision to create sustainable and beautiful buildings. Then there were numerous sustainable strategies incorporated in the design to make the new building perform optimally. These include photovoltaic panels, daylight systems, and reclaimed materials. The library addition features the first insulated rammed earth wall in the country for maximum energy efficiency in an extreme high altitude climate. There was a consultant that we used, Sirewall Construction, up in the northwest that worked on these walls. And so if you look at this little photo right here, it's of basically we put 4 inches of insulation between these two rammed earth walls to actually get an R value of 33. A typical rammed earth building only actually has an R value of 5. So in this region, it was very important to get a really insulated exterior wall. And I'm just going to show some photos of this building so you get an idea of what a rammed earth building can be. That's the new entry. This is the community center. This was beautiful soils in the area. It obviously has a little bit of iron in it. You can't predict exactly what the layers are going to look like. We were quite lucky, I think, with the way it turned out. There's Corten steel above, and there's we used Doug fir timbers. We also used reclaimed wood. It's a reclaimed wind fence that you find in the southwest for basically it blocks snow from getting onto highways. So that's the barn board that you see, the barn-looking board. We used concrete that's exposed, so we're not covering it with flooring. We're just making it beautiful. We're putting an acid wash off on it. We used rammed earth on the interior. This is the front desk. And this is the community room. Collections. Details. So although this case study did not use a third-party verification checklist, it was successful because the construction used materials found close to the site. This created a building with a smaller energy footprint than typical construction methods that imports building materials. Just more details. Details of the wind fence. Details of the Corten. Okay. So I think I have one more case study, but if we have questions right now, that'd be great. But if it's dead silent, I can go through the next case study. Does anybody have questions so far? Or at all? Bam. Oh, we got 2. All right. One of the other. Back.
These are all really beautiful buildings, but they seem to be kind of more of commercial buildings. Are there certain things that when there's a general green building going up that everyone seems to be doing or that are easy to do?
As far as if you're working on commercial buildings?
No, just any building, like design, materials, like what's the easiest way that you can do green building?
The easiest way? Well, I mean, just be thoughtful of your site. Make sure that it's custom to the site. Make sure that you're bringing everybody in right away to talk about what you can do that's green. That that's appropriate for the place.
So say for New England, like, what's something that you should keep in mind when you're trying to build in New England?
Well, that's a good question because some of the checklists actually account for them. They have these regional priority checklists. And so what they try to do is they try to say, okay, you're in Vermont and, water efficiency isn't like the big issue. In Nepal, it's a very big issue, potable water. So we're going to focus more on, having a building that's really energy efficient. And so here in Vermont, with a really cold climate, that's you gotta do that first. That's just irresponsible not to build a really tight envelope and really be able to know what energy is being used and to understand that. And not that that's not important everywhere, but when you're on the equator and you're working, it's just you're using natural ventilation. Heat's not the issue, and keeping it tight. There are other issues there. So so it really varies, and you really have to be conscious of your climate, right away. Where you're working. And if you do that, then you're not just building anything and anywhere America. And that's really important. I mean, I can go on, but I probably shouldn't. Get me revved up.
Any others that are on your mind? Just
Oh, yeah.
It's
right here.
My question was, how much money has been spent on each of the buildings? I mean, I like what you've been showing us, but what is the economic effect on the monetary cost of each project?
The clients vary so much. My final project is completely different than the others, which is why I'll flip through some slides. But it really just depends on your client and what their needs are and what they can do. So the K through 12 school in Sofia, Bulgaria, in the States, that would cost probably double or triple what it costs there because local labor is a lot less, So there are a lot of people on site. That's not where your costs were. Here, labor is going to be a big issue. Not issue, but that's where the costs go. So that really varies on your project and what region in your country, what region of the country. But usually the client says, this is how much we have, what can you do? And you strategize that way too. I mean, so that's all part of the early design process.
Any others before we go to Nepal?
We want to go to Nepal. It's very exciting. You got one right here.
Yeah, kind of piggybacking off that thought for monetary cost. Going back to the Norwich case study, I was curious. You said the homeowner received $30,000 as opposed to 1%. Could you clarify a little more what that was from?
Yeah. So Efficiency Vermont. I'm not sure where they get. I'm not sure how they get cash back, but that when we work with Efficiency Vermont and you use like energy efficient fixtures and they monitor, what mechanical pieces you're putting into the building, they actually will give you money back for using particular items. So that's great. The 1% I was talking about for LEED, when you do a LEED project, you actually have to pay the USGBC to sign up and to monitor, because they have a person there that's like third party. And so you have to pay for that. In addition, not only do you pay the USGBC when you do something like that, so you have to have a client that does have that money. That's why that question comes up, because you don't have to do a LEED project to be green, but it does help. It makes everybody accountable. So sometimes the measures that you take, like renewable energy is a big one. It does cost money. So the client sometimes doesn't have it. So if you can't, you got to really just go for the tight thermal envelope. Just do take as many measures as possible. That's why it just varies a lot with a LEED project. So I say 1% because that's about what 1% of the construction cost is about how much more you'll spend typically.
You can answer this even as a yes/no question, but having done projects that are both LEED certified, Efficiency Vermont certified, and other green certifications, would you say it's worth the trouble of going through the certification process or just following your own gut instinct on what a green building is?
That's a good question too. It depends on your client. You have clients coming in, and it depends on your design team and how committed people are. Anytime I go into a project, I want it to be green. I want it to be sustainable. So the client doesn't always get that, the team doesn't always get that. So if I have a committed team, you don't necessarily need to do the green checklist. The good thing with a green checklist, no matter what, even if you have a great green client, is that you're always going back and you're checking things. You check things off. But sometimes you don't have money, you know. So it costs a little bit more. So then you figure it out as a team. But you have to be really diligent, even a good team. So I would say if I had a client that wasn't on board right away, I would try to get them to do a certification program. Anything else? All right, you ready to go to Nepal? Okay. All right, so the fourth case study is a series of projects that I've worked on in Nepal. Up there you'll see, this is basically a typical terraced landscape that you'll see when you go to Nepal, and it's all agriculture. It's gorgeous. It's amazing that they're built. They do the agriculture on these terrace landscapes, but you'll see it everywhere. So the Edge of Seven is a non-for-profit that seeks to create access for educational, health, and economic resources for girls and women in developing countries through architecture and infrastructure projects. Currently, I'm on the architectural board for the Edge of Seven. The Small World partners with the Edge of Seven. The Edge of Seven's out of Colorado. The Small World is a Nepalese group, and their mission is to make a measurable difference in rural Nepal communities by investing in education, health, and different sustainable community development projects. In Nepal, 38% of Nepal's population lives on less than $1 a day. 55% live on less than $2 a day. 59% are illiterate. And educating girls breaks the cycle of generational poverty. In Asian cultures, in many Asian cultures, females are undervalued and invested in disproportionately, since they will eventually be given to the grooms of the family. So daily domestic chores and unskilled labor fall disproportionately on girls, depriving them of educational and economic opportunities. There. In 2013, when I was at Truex Collins, we started a campaign to support the Edge of Seven and their projects in Nepal. Through the office, I designed a community center for the Manku village firm. This is where victims of sex trafficking or domestic violence were able to go. As a result, they typically possess agricultural skills but do not have independence. This is known as Her Firm. This project helps women in situations develop skills to live independently. The project created a community center with a classroom and computer lab, as well as a health center and daycare. So we did this abroad. We didn't actually get to go to Nepal for this project, but it's the first project, and we were doing this work pro bono. You can see the terraced landscape there. And this is a section of an earthbag building, which I'll explain in a little bit. So the Basa School was a second project, and it's one of the funded projects by the Community Development Program. It's a building. The building was for a higher secondary school in Basa village in the Salakumbu region. Basa is one of the largest communities in the Salakumbu with a population of 4,000 people. It's an 8 to 10 hour trek away from the district capital of Salari, where the other higher secondary school is located. Prior to beginning this project, there was only one other higher secondary school in the entire Everest region, and that served 34 districts with a total population of 170,000 people. Because of this, many students in the Basa region were dropping out of school after grade 10. So here's some sketches from my notebook, just the location in Nepal, India, China, which you probably already know. This right here is a more local map. You can see Basa village off there. The little dots kind of show where we trekked from the Fat Blue airport, which we helicoptered into. And then it was a 2-day trek to Nepal before we even started building this project. And then the loop kind of goes around. On our way out, we did a 2-day trek out. So in November 2013, our group of volunteers embarked on a trip with the Edge of Seven and a local partner, The Small World, to go to Basa village and build 2 classrooms. It was a trip of a lifetime since we were only going to trek. We were going to trek in what I think is one of the most beautiful parts of the world in the Himalayas. But we're also going to build with natural building materials, a school that could greatly improve the life of others. There we go. The trip began when we left the harmonious discord of Kathmandu, and you can see that over on your left. So that's when we're flying out of Kathmandu, and we flew into the Phaplo Regional Airport. It was a calm and nice day in November, and we landed and met our guide for the couple of weeks, which was Dawa Sherpa, and a couple of porters. So from Phaplo, it'd be another 2-day trek to Basa. The journey took us over a 10,000-foot pass, so not so high considering you're in the Himalayas, and we stayed in this monastery. So we had a chance to kind of experience, you know, what people did just to get to their villages, and so we were greeted by this group of monks, and they were chanting when we first got there, and we stayed overnight there. Sketches, do lots of sketching. So the monastery and the courtyard. So when we arrived there, we were greeted by a festival. We hadn't even done anything yet, and everybody kind of greeted us. They did traditional dance and folklore. So it was a great honor to be greeted in such a manner, and an inspiration to begin work on the site, since we hadn't actually done anything yet. See some of the kids. And these are some of the houses that we stayed in. The women all stayed with the headmistress in these houses. So these were some other earthbag buildings were built, so I just want to show them. On the lower right was actually another project in Basa Village. It's a 2-room classroom, so you'll see what the completed one looks like. On the left is another earthbag project in Philaele. Now, in the upper right, you'll see a section of a typical earthbag school. Ooh, well, you'll see another section here. This is a sketch from my notebook. So you dig a trench and put in basically quarried rock. So you're not using concrete, but you still have to go fairly deep for the frost level. Above that, you stack bags. They're rice bags. They're really light, and it's something, they have rice in the region, and so they're readily available. So in the bags in the first courses, you put kind of aggregate that you kind of chop up by hand. And then above those first courses, then you have the sand and the mixed with earth. And the top course is a concrete ring bead that you put on top, and then on there you might use bamboo for trusses. So it was a 2-room classroom that we were building. When we got to the site, this is what it looked like, and it's a flat site, and that's amazing in itself. They had to do a lot of work to flatten the site, so we didn't actually do that. But we did start trenching the very first day, and this is the first day's work. The masons you'll see over to the right, the Nepali folks are just amazing masons because they are doing, if you see all this terraced, the agricultural from the air, I mean, they do this all by hand. So they're very quick to lay dry stone. And these are more progress photos. You'll see the quarried stone coming in. That was a quarter mile to a half mile away, and we carried the stone from the site. The community helped out. You see in the upper right, you see a gal that's hauling stone, and she's doing this on this contraption that kind of goes around your head, and they place them on the back. We tried using them. They didn't work very well for us. It's something that they've worked on for a very long time, so we'd carry them in hands and on stretchers. Some of our group, these are stitching up the earth bags, so the rice bags. On the left, you see this guy. We also got the wood locally, and so they would chop it right there on site. They'd fell the tree and they'd chop it up. You notice he has bare feet. Obviously, he was pretty precise when he was when he was sawing. But you see this in different parts of the world too. But they were pretty amazing, and the timber was gorgeous. I mean, look, it's just this warm, beautiful, local timber. So more progress shots. You'll see the quarried stone It's the base of the foundation, and then the first row of an aggregate in the bags. That's for drainage. And this is our group in the lower slide. And then the upper left, you'll see some more courses going up, and that's more the sand and earth mixture, as well as you see a couple of doors going up. And this is actually another project, but we didn't complete the project. There was another group of volunteers that came later to complete it. But you can see that they used a plaster held on by chicken wire, something that we've done. I've done a straw bale building. It was quite similar. It's a heavily seismic zone, and so we did actually put rebar in between courses for lateral stability. And the Edge of 7 really wanted to make sure that we had a really a good experience and really understand the community. So they had, not only did we stay with everybody there, which was fantastic, we also had opportunities to teach in the classroom.
We should probably,
Oh, I'm done. All right. So, although we didn't have time to complete the building, as I said, it was completed by another group of volunteers. The new facility will accommodate more than 200 students every 2 years, and it will be accessed by students from neighboring communities. So in conclusion, I've had a very fortunate journey thus far as an architect. I've been able to work on socially conscious projects, had fantastic clients, and been able to create some pretty and sustainable buildings. So hopefully these 4 examples show a wide range of green building approaches at different scales and different regions all over the world. So.
thank you.
Sorry.